Hi guys, it's Mr. Collins. I'm back at it again with the math videos. Today we're going to look at exercise 9E, which is probability tables, which is also a revision from last year, so hopefully it comes back to you pretty quickly. So rather than drawing Venn diagrams, what you can also do is take information from a Venn diagram and actually input it into a probability table like we have here. So basically it's just matching up the columns with the rows. So in the B and A here, this intersection would show you the probability of A and B, so the intersection. Intersection of A and B. And then here would be the probability of A and not B. So just of A. Okay? So if this is the intersection, so if we're drawing this out here, so we've got the first one is the intersection here, and then probability of A and not B would be this stuff here. Then if we add these two together, like we would in a regular table, we'd get the probability of A. Because we've got the intersection plus the probability of A and not B, so eliminating this intersection here, you also have the probability of A. So down here, quite similarly, in a similar way, you've got probability of B and not A, and the probability of not A and not B. So we'll put a box around here. Okay, so then you've got, if you add this together, so probability of B and not A, I'll change the colour here just so we can get a bit. So B and not A and not B, so that's all the outside here, which is A dash. Then you're going to be left with everything except for, sorry, that should be on the inside. So that would show up in here, probability of A dash. So we know, and that's the complement of A. So I've actually should have added a row below here. Let's see if I can do this quickly. Couldn't be bothered. We can add it in ourselves, guys. No worries. So probability of A plus probability of A dash, when you add a complement, two complementary events, that adds up to 1. Similarly here, when you're adding along here, probability of A and B plus the probability of B and not A, just like we had the probability of A here, that would be the probability of event B. Other way you can look at it is just look at the column, the B column here. If you add both of these probabilities together, you're going to end up with probability B, and this is going to be the probability of B dash. Okay? So that's how you set up this table. It's a bit confusing if you look there. Hopefully you're running through that probability of A helped you out. I'm going to get started on an example here. So basically what you do is you give them a piece of information and then you just got to fill in the blanks here. So if A and B are events such that probability of A is equal to 0.7 and probability of A and B is 0.4 and probability of A dash and B is 0.2, find these 4 things. So first thing you do, don't overcomplicate it. You've got the information there. Let's add it into the table. So probability of A, we know that that goes in this one here. So you'd have a bound reference. You'd include this information there. So that's 0.7 would go in over here. Probability of A and B, so that's where A and B intersect, is 0.4. Make that point big. The probability of A dash and B, so A dash and B is 0.2. Alright, so I want you to see if you can go through and by filling in the blanks, you could actually fill in each of these missing spots. So you've got 6 spots to fill in here. So in between videos, it'd be good if you guys could have a crack at answering this in your book, and then we'll go through it in the next video.